This is make or break.
The high-altitude, low-speed run succeeds. The bombs cover the entire grid in a wide pattern, each impact roughly 120 centimeters from the other. It's a great start to the project.
High and slow, accuracy, fantastic!
Business executive Kevin O'Leary has arrived. And he's impressed with the results.
This looks like a forest. It's a blueprint of a forest here.
But when Basil raises the safety issue, Kevin's antennas go up.
Slow for the aircraft we've been using is approaching stall speed.
Yeah, but stalling an aircraft, you're going right into the ground upside down on fire. Bad.
Despite the successful results, Kevin vetoes the Skyvan. Aerial reforestation of the planet by fixed-wing aircraft is just too dangerous.
Helicopter is a better means of delivery than the airplane. The helicopter gives you the ability to control your speed from 0 to, say, 70 or 100 knots. Also gives you the ability to pick up more seedlings at very remote locations. You don't require an airstrip.
But there's a problem with choppers, which is why we didn't choose them in the first place. They've got a limited cargo capacity compared to most planes. So now we've got to devise a brand new way of delivering loads and loads of canisters.
But before they tackle that problem, Mark has the perfect place for the experiment. He's already shown them one striking example of the challenge ahead. The wetland forests of the Mississippi Delta, devastated by Hurricanes Rita and Katrina.
Let's head offshore.
But out in the Gulf of Mexico is another chapter in this tragic tale of deforestation. This is where Mark wants to make his stand. The Chandeleur Island chain is a natural storm barrier, stretching 80 kilometers. The islands used to be covered by mangrove trees.
The barrier islands out here provide protection from tidal surges and waves that are associated with storms. But over the years, the hurricanes have blown those islands and the mangroves on them away and no longer provide that protection.
Without mangrove trees to hold the soil, this island, called Newcut Dune, has eroded almost to the waterline. When Hurricane Katrina hit, the storm surge was free to roll right over Newcut and the entire barrier chain. It then slammed into New Orleans and flooded the coastal forests with salt water. Mangrove forests used to thrive in a broad belt around the world, but they're rapidly disappearing, leaving many coastal areas vulnerable to storm surges and rising sea levels. Reforesting with mangroves would help restore these natural barriers. Even more important, mangroves are one of the most efficient CO2 scrubbing trees on Earth. So reforesting them here is a powerful idea with global significance.
This is why we're here south of New Orleans. And this is where I want to test aerial reforestation.
All right, what's the game plan here?
If you have 2 men out here manually planting mangroves, you may get 1,000 or so in a day. With one pass, we can drop 1,200, 1,500 mangroves.
So if this works now, 10 years from now, on this coastline will be a protected piece of land because it will have on it a mangrove forest.
That's correct. This is ground zero for aerial reforestation.
If the mangrove forests of the world's barrier islands were replanted, the benefits include not only protection from rising sea levels, but CO2 reduction as well. A double blow to global warming.
If this technology works here, it'll be applicable all around the world. Anybody that suffers this kind of devastation could use what we throw here.
To regrow any forest, you need seeds, and mangrove seeds are called propagules. With help from local environmental groups, Kevin and a small group of volunteers head for a stretch of mangroves deep in the Mississippi River Delta.
Hey, Basil, it's Kevin. And we are picking mangrove seeds like crazy. We've got thousands of them. Timing's perfect because they're just falling off the bushes right now. Good work, guys. Tremendous. Oh, yeah. Yeah, these are all prime specimens.
Aided by the volunteers, the team has collected a huge batch of 15,000. But they still need to design the canisters that'll contain them.
If the canister doesn't work, everything else is for naught. So we've got to get the canister right.
Mark's original idea was to pack the seeds in high-tech canisters made of advanced materials. But for a global reforesting effort to be feasible, the canisters have to be made from less expensive, more accessible materials. So the team must now design a seed canister that can be easily manufactured by hand, with local materials, anywhere in the world. And the design has to serve 3 critical functions.
First, it has to serve as a means of protection for the seed or the seedling while it's in the aircraft or in the delivery mechanism. Secondly, it's got to serve as a means of properly delivering that seed all the way to and including impact on the soil. And third, it has to provide nutrients and fertilizers that'll protect the seed and seedling as it strikes root.
Now they have to see what happens when low-budget canisters smash into the earth.
Worst case scenario, when we drop our canisters, they're going to be traveling at terminal velocity. We're simulating terminal velocity by firing them out of an air cannon. We're going to see how the propagule survives. Has it been crushed? Is the root system still intact? Or have they just vaporized?
They have 5 designs to test. Each has to be cheap, biodegradable, and easy to mass manufacture. First up is Basil's bomb.
The finished product would be made out of some sort of thermosetting starch material which would biodegrade. 5, 4, 3, 2, 1.
I see death and destruction everywhere, my friend. There's problems here. Design is completely flawed.
To study the impact, they film the results with a high-speed camera.
That's the wadding, right?
Yeah, that's the wadding.
The seeds end up way above ground.
They test several more designs.
All right, a sock. The problem is, it didn't break up enough. It may entomb those seeds. That is an issue. A paper bag.
This is so low tech. 3, 2, 1. There's no penetration. I think if a wave came along, it would take that away. 3, 2, 1.
Look at the seeds, they're destroyed.
That went right through the bottom.
That's a horrible design. Look at that.
I just need to back off on the pressure.
That has just been mushed.
Finally, Mark designs a canister made from melted wax. He hopes it'll protect the seeds while getting some penetration.
I think this will win. Force equals mass times acceleration. Bam.
3, 2, 1.
Whoa! That looks like it has possibilities. That's really good. Very nice.
Mark's design fits the bill. The rigid wax holds its shape in the air. It also helps the canister penetrate the soil. And when it hits, the wax shatters, so water can seep in to start the seed growing.
We have some seed survivability, we have penetration, we have a combination that we